We've heard ChatGPT just predicts the next word. Technically true, but oversimplified. In reality, its code is a massive web of math, patterns, and data stitched together into one mega brain that obsessively plays a never-ending game of finish the sentence. Welcome back to PandaProgramming. Starting with this video, I want to look behind the curtains of different software, tools, and games. If you've wondered how big software systems work, stay tuned for upcoming videos. Here's where our journey begins. Meet the Transformer, an architecture invented by Google in 2017 because they got bored one day and decided to completely change the future of computing. The Transformer is built around a mechanism called self-attention, which sounds like the kind of thing a therapist would recommend, but is actually a mathematical superpower, one that makes the whole model work. Instead of reading text one word at a time like normal humans, Transformers process all the words in a sentence simultaneously, kind of like having a brain that can look at every word at once, compare each one to every other one, and decide which relationships matter. When you ask a question, the model is not just glancing at the last few words, it is scanning the entire sentence, the conversation history, and the patterns it has seen in millions of similar conversations during training. Training is the part where OpenAI basically force feeds the model half the internet. Books, articles, web pages, research papers, all pass through GPUs, insanely powerful. If the model predicts wrong, the system adjusts billions of internal numbers called parameters. These parameters are microscopic preferences for how the model processes language. After repeating this process trillions of times, the model becomes eerily good at recognizing patterns in human writing. Not because it understands language the way we do, but because it has seen so many examples that it can statistically predict what a reasonable next word or sentence should look like. And yes, I said billions of parameters. GPT models famously scale, which is to say exponentially. GPT-3 had 175 billion parameters. GPT-4 and GPT-5 go way beyond that, though exact numbers are not always published. What matters, the more parameters a model has, the more linguistic relationships it can store, and the more subtle, coherent, and human-like its responses become. This scaling effect is so dramatic that researchers actually wrote an entire paper called The Scaling Laws for Neural Language Models. But here is where things get hilarious. Despite all that power, ChatGPT does not actually understand anything. At least not in the philosophical sense. It does not know the difference between happiness and sadness, or between a cat and a toaster. What it has are patterns. Absurdly detailed multidimensional mathematical patterns that map every word to every other word. When you ask something like explain quantum mechanics in simple terms, it does not consult a physics textbook. Instead, it looks at your question, runs it through its internal pattern space, compares it to millions of similar questions it has already digested, and produces the most statistically appropriate answer. And because humans are wildly predictable creatures, the model often gets it right. Behind the scenes, your prompt is converted into tokens, tiny pieces of text. Each token becomes a vector, a long list of numbers representing its position in a high-dimensional space. Words with similar meanings end up close to one another in this space, like little digital friendship circles. Then the model runs these vectors through dozens or hundreds of layers, each performing matrix multiplications so large that your personal laptop would start smoking if you tried to run even a tiny fraction of them. And yes, it is all still just mathematics. No consciousness, no emotions, no secret plot to take over the world, just pure linear algebra wearing a very convincing human mask. Once your prompt finishes passing through all those layers, the model produces probabilities for the next possible token. It is not choosing from just 10 or 20 words. It is choosing from tens of thousands of possibilities. The highest probability token becomes the next part of the answer. Then it repeats the process again and again and again, sometimes thousands of times per reply. This is why ChatGPT occasionally rambles. The system is essentially playing linguistic dominoes, and if it gets one piece slightly wrong, the rest of the chain can wander into philosophical nonsense or creative chaos. And then there's the part nobody talks about: reinforcement learning from human feedback, commonly known as RLHF. This is the stage where human testers essentially argue with the model, correct it, rate its replies, and force it to behave like a polite, socially acceptable digital citizen. Without RLHF, large language models talk like emotionless encyclopedias or rebellious teenagers who just discovered Reddit. RLHF acts like the finishing school of artificial intelligence, smoothing out the weirdness, teaching it not to say offensive things, and training it to answer in a helpful way instead of going full chaos mode. Now here is where things get both impressive and slightly concerning. After all that training, all that data, and all that mathematical madness, ChatGPT still needs something called a tokenizer to chop your beautifully written sentences into tiny pieces it can actually understand. The tokenizer slices your text into chunks it calls tokens. Sometimes these tokens are whole words, sometimes they are half words, sometimes they are random syllables that look like the result of a keyboard sneeze. They could be anything. The model does not care. All it wants is numbers. So once your words are broken down into tokens, the system transforms them into numerical vectors, because at the end of the day, every idea you share with an artificial intelligence becomes a long list of floating point numbers inside a giant mathematical maze. When the model generates a response, it does not do anything magical. It just moves through that maze with enormous speed, stacking mathematical operations layer after layer. Each layer takes the previous layer's output, mixes it with every other layer, consults those billions of parameters it has stored, and makes a microscopic adjustment to its internal guess. This happens again and again until the model is confident about what token should come next. It is almost annoying how simple the core idea is compared to the monstrous engineering required scale. But this is also why artificial intelligence is so addictive to researchers. Something that seems almost stupid in its simplicity can become unbelievably powerful when scaled to extremes. These layers, by the way, are not just stacked on top of each other like pancakes. They are interconnected in ways that allow the model to reference earlier parts of your text, to pay attention to the right words at the right time, and also to suppress irrelevant information. If you mention something at the beginning of a conversation, the model can keep track of it 30 sentences later. It does not remember it by storing a memory in the human sense. Instead, it remembers by keeping a representation of the earlier text active in the internal mathematical space. This is why ChatGPT can maintain coherence across long conversations, even though it is technically not remembering anything permanently. See how everything is just careful manipulation of attention within a sea of numerical relationships. Now, even after all this engineering, the raw model would not be something you would want to talk to. Before deployment, these models go through something called temperature tuning and sampling strategies. Temperature is essentially a dial that controls how creative or conservative the model's responses are. Set it low, and the model always picks the most probable next word, making it sound predictable and robotic. Crank it up high, and suddenly it starts generating wild, unexpected responses that can range from brilliantly creative to completely nonsensical. Companies like OpenAI carefully calibrate this setting to find the sweet spot where responses feel natural and helpful without going off the rails. There are also techniques like top K sampling and nucleus sampling that filter out unlikely tokens before the model even considers them, preventing it from occasionally spitting out complete gibberish in the middle of an otherwise coherent answer. But make no mistake, under all that politeness and conversational polish, the model is still doing nothing more than crunching numbers and predicting words. It is not pondering the meaning of life or deciding to emotionally invest in your problems. It just happens to be extremely good at generating human-like text and extremely consistent about following the patterns it has learned from its training data. And when I say training data, I do not mean a few gigabytes of text. Large language models are trained on datasets so large that if you tried to read them all, you would grow old, retire, and still not finish. The servers running models like GPT are equally absurd. These systems operate on specialized hardware, often clusters of GPUs or tensor processing units that process enormous calculations in parallel. When you send a message, it triggers thousands of mathematical operations that happen in milliseconds. The response feels instant to you, but behind that instant response are hundreds of machines, all working together to produce a single sentence. Think of it as a digital swarm of calculators cooperating at light speed while never complaining about workplace conditions. This entire setup creates the illusion of intelligence. And yes, I call it an illusion intentionally. ChatGPT does not have beliefs or desires. It is not planning anything. It is not secretly sad, excited, or even bored. It is a sophisticated pattern recognition engine with a very convincing personality layered on top. The illusion works because humans naturally assign intention and meaning to anything that communicates with them in fluent language. If a toaster could suddenly talk in complete sentences about astrophysics, you would probably think it was a genius. But behind every elegant paragraph the model generates, there is nothing but mathematics. Beautiful, complex, terrifyingly large-scale mathematics, but still just mathematics. And with that, we've come to the end of today's video. If you found this video informative, make sure to smash that like button and subscribe to our channel before you leave. Thanks for watching. I'll see you in the next one.